Hello. Yeah, thank you for coming for my talk. I'm Lee Sanders from IBM UK. This talk is kind of in two parts. It's about the pitfalls that you can fall into for doing performance evaluation of storage systems. And also the second part is around about some tooling to make your life easier with benchmarking of your Ceph clusters. I've been doing performance evaluation of storage systems for around about 10 years, 2 years on Ceph, and I'm very excited to be able to share some of the knowledge and insight I've gained over the 10 years. So thank you for coming. So to start with, when you're doing performance benchmarking, you're not really necessarily interested in the max IOPS and max bandwidth unless you're really interested in the system limits. Typically, from my experience, knowing the max bandwidth and max IOPS is really only interesting for marketing type material. And it's actually more interesting to draw a graph such as what we can see on here, which is show as throughput increases how it actually affects latency. And from drawing one of these graphs, you can also understand how demand grows over time. So as you expand your storage systems, what your limits, upper limits of the system's going to be. So on the next slide, so a lot of my slides involve drawing response curves. You might have seen a few of these if you went to Bill and Alex's talk yesterday. These got two names, a response curve or otherwise known as a hockey stick curve. And it's called a hockey stick curve just because of the nature of the shape of the graph. So how do you read one of these graphs? So essentially, you start off in the bottom left-hand corner. There's actually two ways you can draw these graphs. You can draw it backwards or you can draw it forwards. But essentially, it's plotting throughput against latency. So you start off in the bottom left-hand corner with a very low queue depth, and then you plot what the latency is from that particular point. And then you gradually increase the queue depth and then plot the next point of the curve. So, but for each data point, it essentially represents an average throughput for that duration. So typically around about 3 to 5 minutes per point of the curve. But the response times include everything in the storage system. So switch, network, overheads, and so from the application's point of view. So the shape of the curve is actually quite important, so because it represents an indication of consistency. So a flat line along the bottom represents that you can actually see that it provides more consistent throughput and latency. And you'll see later on in my talk that consistency is actually really important, which is something that most users and customers actually care about. But before you generate one of these response curves, it's important to put the system into a steady state by preloading the system with data in a client-like fashion. Another thing to point out is that most users want to understand how much scope there is for expansion of the system. So typically most users don't really want to operate any more than 70% of the actual curve where the curve actually starts to increase. So that kind of gives you around about a 30% gap before you start hitting the system limits. So on this chart, so as I mentioned, that my real-life workloads contain peaks and troughs. You'll see an average and a maximum. And you're interested in also knowing what the worst-case latency is, particularly during events. And as I mentioned, users prefer consistency over a spiky like workload. Such as on this chart, where you can actually see some kind of event about a third of the way through, such as an OSD or maybe a node reset, and there's quite a large latency spike. But understanding these variations is actually extremely important. But you can also mask some of these latency spikes just by the way that the graph's drawn. So if you draw the y-axis with a short range, you can actually mask some of this. So just by generating a chart with the wrong formatting can actually mask some of these latencies. So you have to be careful about how you plot the actual data. So some variance is going to be inevitable. Around about 5 to 10% is to be expected. I'm not going to go through all of this of these bullet points, but all of these bits on these bullet points can affect how you compare data from one run to the next, such as number of nodes, CPU speed, even the flash type can make a difference. But there's some other points as well, is that the workload ordering can also affect how you do your performance evaluation, and that can actually affect the results, even down to pre-filling and preconditioning and the capacity of storage. So I'm going to talk about some of the gotchas that you can fall into when benchmarking your cluster. Pre-filling is extremely important because you want to be reading data that was previously written. So if you don't pre-fill it enough, then you'll actually be reading unallocated space and not doing the IOs to the OSDs. Preconditioning is important because you want the system to be doing garbage collection and some element of defragmenting that you want on the system as the data is overwritten, because in the real world, most systems have been running like 6 months, maybe even a couple of years, and they'll all be doing garbage collection. So you want to be able to really measure what real users are actually going to get. For consistent and repeatable performance, for repeatable, you want to disable things like scrubbing, deep scrub, balancer, and autoscaler to get repeatable. But for real world, you want to have these features turned on, but we'll give a few % difference, and latency will slightly be more variable, but it will actually be real world. Volume size and working set. So these can have a huge factor in the performance results. So if you've got small volume sizes, and you do a read workload, your reads can actually fit all in a cache, and actually you won't be measuring any performance of your OSDs. It will be coming straight out of cache, and it'll give you an artificially inflated performance result. And small volumes can also trigger overwrites versus cache misses, which can also affect results. You also want to consider your PG configuration. So if you've got large PGs and with a low number of placement groups, what can happen here is that you end up with OSD thrashing. So you'll just be sitting there hammering 1 or 2 OSDs when to get best performance, you actually want to be spreading IO over more of your OSDs, and you do that by having more placement groups in your Ceph cluster. Another common problem is that most modern CPUs have power and frequency governing enabled, which can cause the CPU to enter sleep states when idle. And typically you want to have this feature of the CPU disabled, so with a tool such as tuned ADM, so that the CPU is not going to govern the frequency and the power. So I'm going to talk about the next part of my talk, which is how do you generate repeatable and comparable performance, and some tooling that me and my team have been developing. Can I have a show of hands who's heard of CBT in this room? Oh, that's good. That's a very good sign. How many people are actually using it? Oh, yeah, not so. Okay. Well, hopefully, what some of the things I'm just about to share with you, with the improvements I'm going to talk about today, that we want to get the community using CBT more. So from the last 2 days, I've been talking to quite a few people, and actually there was in one of the panel sessions yesterday, 2 people put their hands up and said it's actually quite difficult to do sizing with Ceph clusters because of the huge number of configurations. So one of my visions with CBT is improving CBTs, that it will become the way of evaluating performance of benchmarking performance of Ceph clusters, and by if we can persuade the community to start adopting this as an easy way to evaluate Ceph clusters, then we can build up a repository of performance data from the community, almost like crowdsourcing performance data from the community, given that there's a huge number of different configurations out there. And with performance sizing of customer systems, when you're doing POCs, you don't really need the exact configuration that matches with the POC you're trying to demonstrate to the customer. It just needs to be good enough and an approximate. So for CBT, we want to have a single-click standardized test methodology for object, block, and file with comparison results and comparison tooling. And as I mentioned, use this as a standard way of evaluating performance in the community. So we want to generate like 30 plus hockey stick curves, and I'll explain in a minute why we want to generate quite this amount of data. But we also, at the same time, still want to maintain the developer-like focus of understanding what the bottlenecks are of CPU utilization, and also with the code profiling features, and upload results to a GitHub repo for everybody to see. So one of the things we've radically improved is the report generation. So you can actually supply multiple sets of data and generate comparison reports like you can see on here. One of the main problems with supporting multiple I/O exercises, such as object, block, and file, is the wide range of I/O exercises that we need to support. To do this, we added a new intermediate format, which gets generated by for the graph. And so every time we add a new exerciser, all we need to do is create a new thin layer that converts the I/O exerciser into the intermediate format, such as FIO. And this means you avoid needing to rewrite the report generator for every exerciser that you support. Reports are generated in PDF and Markdown format, which are easily viewable in GitHub. So I mentioned about the 30 plus hockey stick curve. So why are we generating so many different types of I/O? So for large block sequential reads, these are typically equivalent to like a object get operations, and large copy and backup type operations. Large block sequential writes, because these are equivalent to like large object puts and also backup workloads. And small block reads and writes and mixed, equivalent to what most file systems would actually be issuing to your storage and transactional workloads. And large random reads and writes are equivalent to reading large files in Ceph. We've also improved the reports summary, added a report summary table, so you get an n-way comparison table for best throughput, which basically plots the best throughput in the curves. Why is this interesting? Well, typically, when you're doing a POC, the request will be, what is my performance at, say, 2 milliseconds? And so we could tailor the table to show that I expect to be able to get like 50,000 IOs at 2 milliseconds. So we can show a table here of what the performance is depending on what your POC is. One of the key features that's enabled the repeatability and deterministic approach of doing the performance evaluation is a new workloads feature within the YAML. Initially this was only added for librd FIO, but we've just refactored all the code so that we now support this for other benchmark types. There's two ways of doing this, is the IO depth and total IO depth. The difference is with IO depth, say you had a 16 RBD volume configuration, drawing a response curve with 16 volumes means that each point was scaled at Q depth by 16 volumes. But with total IO depth, it allows us to go finer grain than that, and it allows you to split up, have different volumes doing different Q depths, and you actually get a finer grain control over the IO depth. We've also added a script syntax so that which we've found extremely useful for measuring fast EC, for measuring what the performance is of empty capacity versus populated capacity, so you can actually delete and recreate volumes in between each point of the curve. Another thing that's we're currently working in progress is CBT has had lack of Ceph ADM support, so we're currently writing a configurator generator to make creation of the Ceph clusters much more simpler. And this gathers the details for inclusion into the performance report, so you can actually show what's been tested and help others recreate what was run in the performance report. So it includes details in the configuration such as the Ceph commit version, the number of OSDs and the volume size and the erasure code or replica config and so forth. So as I mentioned, we want this to be a single click. It is currently two-step. So it's two-step, and you create the config and then you do the performance run. We are working to improve the documentation to make it provide better guidance on writing YAMLs and provide sample YAMLs on how to tailor the YAML for your particular system. We've been focused on block at the moment, but we're working on expanding it to support other IO types, KRBD and the NVMe gateway, and we are super keen on evaluating S3 object with Warp, LBencho, and other object exercises such as HSBench. I mentioned about a common repository. I've got some sample URLs that feel free to take a look at here, which has got some example performance data that the report generator currently supports. But obviously, as we're adding new features, the report will get improved. So another feature we're working to add is the ability to be able to add it injects at node times and measure the performance impact. I talked about a little bit earlier about being able to measure throughput over time and show the peaks and troughs. That's the sort of chart that we want to be able to add to CBT, so you can look at the impact of scrubs and RocksDB compaction and OSDB starts. So, yeah, we'd like to be able to understand what the performance is in the event of a failure. We also want to add support for histograms and percentiles. So this is useful for understanding the consistency of performance. Quite often users ask, say, I want to be able to guarantee 90% of my I/O at certain milliseconds, certain latency. We're working on adding support for network utilization, back-end drive utilization, and measure the CPU utilization at the OSD and client gateway levels. So this will be very useful in understanding what the resource bottleneck is that's limiting the performance in the report. So we're working on a series of blogs by Jake Squelch on Ceph.io. The blog's almost written up, so this will provide some very useful guidance on how to use CBT. And we're also working on part of the blog series is to be able to answer questions such as how does Clay erasure code benefit or compare against JErasure, and also use CBT to be able to compare different object exerciser tools such as LBentro versus Warp. And part of the CBT run, we want to be able to just generate a report automatically. This will really actually be very useful for integration into tautology, where you could then almost be able to use CBT to say, well, for this particular build, here's a performance report of it, and then automatically compare that against another build for regression checking. So I'll throw that out there to the community, is what other performance comparisons do the community want answered. I don't have to ask now, but go away and think about it, and then come back to me if you've got any suggestions. So that concludes my talk. Thank you for listening. Be interested in hearing your feedback. If you want to get involved in this project, please contact me or Chris Harris, Jose, and Jake Squelch, who all have been valuable contributors to this project. Reach out to me on Slack. I'm on the Ceph Performance Weekly run by Mount Nelson every week. That's it. Thank you for your time. I think we've got 5 minutes. Any questions? Yeah, that's right, yeah, microphone, yeah.
Could you clarify some more on the gotcha you mentioned about small volumes? Is that a case where small volumes might have artificially better or worse performance? And is there kind of a guideline on like what you'd want to use as a ideal size to avoid that?
Yeah, so good question. So yeah, like for example, BlueStore has got a cache in it. If your volumes are too small, then you could fit the working set. So you may not necessarily be small volumes, but it could be the address range that you're working over. I'm just making it aware that you could actually be inadvertently fitting your I/O range all within a cache and not exercising, like getting read misses and doing I/O to your drive. So you might not be getting real workloads to your drives that you might be expecting.
Okay, thank you.
Sure.
Hi, thanks for your talk. Your performance scores look very familiar. I've got two questions and a comment. I'll do the comment first. I think one of the reasons why I've shied away from CBT is it seems very specific to Ceph, and also it kind of wants to get in your business of the configuration of your cluster, and I want to just kind of be able to dissociate that part of it. And I'm more used to having a tool that I can use against multiple different storage systems. I don't know what the solution there is necessarily. But I had a question about, you talked about preconditioning. Does CBT handle that part of the setup, or do you usually have other scripts for that?
Yeah, that's a part of the YAML configuration.
Okay.
So it doesn't handle it, but it's got to be part of the YAML in order to be able to do the preconditioning. Mm-hmm. So the example YAMLs that we'll be providing will include preconditioning as a part of that step.
Right. And then the other thing that we've been interested in doing more is correlation with like resource consumption on nodes on the cluster. It's like measuring CPU utilization, memory, and network. Is CBT doing those in lockstep with each time interval, and are you able to coordinate roughly like how much is resources being used at each data point?
You will be able to. We haven't added that yet, but that is the plan.
Yeah, because that's also valuable in a framework.
Yeah.
Okay.
Sure. Yeah.
Cool. Thank you.
Thanks for the talk. You mentioned that you've got some integration with Ceph ADM to spin up a cluster to like run a benchmark on. Is there any sort of capability right now to like plug into a different system because like internally we have a bunch of infrastructure for doing that. Is there any availability of like hooking up to another system? And if not, is that something you'd be interested in if we wanted to like try and help contribute, get that in?
That's a good question. Not at the moment, but we'll take that feedback on board, and we'll definitely need to consider that.
Sure. Awesome. Thanks.
Yeah, no worries. Any more questions? All right. Well, thank you for coming.